Hello guys, welcome to miniProject. In this video we'll be looking at mini project by the name of machine learning approach to distinguish walking and running. So nowadays electronic market is full of devices called pedometers and fitness tracker. They count number of steps you have taken, distance you have covered, whether you are walking or running, and a bunch of other stuff, right? I wondered sometimes like how these devices perform such measurements. So I decided to make one on my own and share this knowledge of making it with you guys. So in this video, we will make one such algorithm that is intelligent enough to identify whether you are walking or running. And I decided to go with something called machine learning approach. So it is just a subfield of computer science which explores the study and construction of algorithms that can learn from data, and the derived algorithm is then used to make predictions on data. And accuracy of such device depends on quality of algorithm that we obtain from our training data. And don't get afraid by such terms like machine learning and all. I will be taking you through this step by step, and believe me, it's going to be easy. So let's look at what all things you will learn by going through this video. So things that you will learn will be some kind of Arduino programming. You will learn about SPI interface programming, I2C interface programming. Then you'll also learn like how to use SD card with Arduino, as we'll be storing our accelerometer data, which puts its output data on I2C interface and will pass it to the SD card for storage through SPI interface. Then you'll learn a basic of machine learning, and we'll use Octave to develop this machine learning algorithm. So you'll also learn a bit of machine learning, a bit of Octave programming. So let's get started. So I told you that we need to develop an algorithm to identify walking and running, distinguish walking and running. Machine learning approach says that we need data to develop this algorithm. So what kind of data do we need? So data that we'll be using to develop the algorithm is accelerometer data. And what are these accelerometers? So these accelerometers are electronic devices which can measure proper acceleration. So there are actually two kinds of acceleration: proper acceleration and coordinate acceleration. Coordinate acceleration is the one which is like rate of change of velocity, whereas proper acceleration is the one it's not the same as the coordinate acceleration. For example, accelerometer at rest on surface of Earth will measure an acceleration of 9.81 meter per second square straight upwards. By contrast, if an accelerometer is in free fall, it will measure 0. So that's what our accelerometer will be measuring. And by looking at this data, we'll be figuring out some characteristics and algorithm to distinguish walking and running. So and here on the screen is a plan on how we'll be proceeding. So design of electronics to accumulate this accelerometer data and collection of accelerometer data are the first two steps. Then we'll develop the algorithm and test the algorithm. So in this part 1 of this small mini project, we'll be doing design of electronics to accumulate data, and I'll also show the data that is after. So we'll collect the data also in this part, and the development of algorithm will take it in the next part. Okay, so let's get started with our first point in our plan, that is design of electronics to accumulate data. So things that we'll need are one Arduino board. I'm using Dumila now. You can use Uno or anything that is available to you. And then we'll need small SD card with sufficient memory. I think 1 or 2 GB will also do it. Then we'll need one SD card reader from which we can interface through which we can interface this SD card to our Arduino. So what this breakout board will do is to convert this SD card signals to SPI, Arduino compatible SPI format. So these pins are our SPI pins. Next we'll need one accelerometer, and I'm using ADXL345 accelerometer, and this is its breakout board. And as you can see, here it's in X is in this direction, Y and Z is this three is a 3-axis accelerometer with I2C interface. So here if you can see, it's SCL and SDA pins are there. So we'll be using this ADXL 345 accelerometer. And don't worry if you I have mentioned a link to a written write-up of this whole project, so you can even go through that. We will also need a few mail headers, bug strips. Then we need a small general purpose PCB where we can solder everything, our accelerometer board and SD card reader and everything. We can put it on this small module. Then we'll need one small, not small, 4 AA battery holder, which we will be using to power our Arduino board. And we'll need 4 batteries. Then we'll also need styrofoam to stuff the things together, and we'll need tape to bind them together, and of course solder iron for soldering, and some solder wire. So I think these all are the components that we'll need to make this data aggregator. So beside this all hardware components, we'll need 2 software tools. That is, one will be our Arduino IDE that I think everybody will be having, and one more is GNU Octave. That is also a freeware, so no need to worry about any money. So these 2 software tools we'll be needing, and we'll put our data aggregator at the ankle of our body. And I went for this choice instead of putting that on the wrist, is that to wear something on wrist, we'll have to make it really compact, and we'll need small size battery, small size board, and that all will make our things very expensive, and even for some hobbyist, that much of money to spend is not worthy. So we'll go with a small wearable that we'll put it on our ankle with 4 AA battery holder, Arduino board, and all stuff that I just mentioned. And initially I thought it would be very heavy and not practical, but once I put it on my leg, it wasn't such pain. So I think that's the way we'll move forward. Okay, so now let's put our hardware that we have made together, and this is the way we'll be connecting our stuff. So as you can see in this fritzing schematic, that this is the Arduino board. You can use Dimin or Uno, whichever version you have. Then this is our accelerometer board, so accelerometer breakout board. Now SD will go to pin number 4 of Dimin and Uno. For Mega and Nano, there are separate pins for I2C, but in Dimin and Uno, this analog pin number 4 and analog pin 5 I used as I2C, so we'll be connecting it there. So SD gets connected to A4 and SCL gets connected to A5. Then VCC gets connected to 5 volt, ground gets to the ground, and chip select, this is the CS pin of our accelerometer ADXL 345 board, will get connected to VCC. So that's the connection for our accelerometer breakout board. For SD card breakout board, which had SPI interface, will connect MOSI pin of that SD card to pin number 11 of Arduino board. Then MISO pin to pin number 12, clock to pin number 13, CS to pin number 10. So this is the connection for SPI interface or SD card, and don't forget to connect VCC and ground. So this is the way we will be connecting our SPI, SD card, accelerometer, and Arduino. And here are the images for my prototype that I have soldered. This you are looking up is this is the back side of our SD card module that I was talking about, and you can insert SD card from this side into this card reader, and these are our SPI pins that gets connected to the Arduino. And this is the top side. Here is our ADXL 345 accelerometer, and this is the way you should solder, and should not make any loose wire connection or something, so that at least we can be reliable of our system that's is in action. And this is the image of thing powered. So here are four AA batteries connected through cable to our Arduino board. And you can't see, but at the bottom of this green board is our SD card reader, and this is our ADXL module. And these are all things separated out. So this is how your system should look after putting those SD card and all the stuff together. Okay, so now that all hardware is in place, I will show you the code. So here first we are including the wire library. This one is for I2C interface. Then we are including SD card library for accessing the SD card. Then we are defining ADXL module as a macro which points to this address 0x53. And if you look at the datasheet of this ADXL 345 accelerometer that we are using, this is the address through which we'll be accessing the slave. ADXL 345 module acts as a slave to our Arduino master. Then this here is a count variable. This variable counts the number of readings that we have written into our log file in the SD card. Next variable is measurements to take, and I have initialized it to 3,60,000. And this is the number of desired reading that we'll be writing to our SD card. You can change this number as per your desire, whatever you want to keep. Then here is byte variable for 6 array of 6 byte variable. This will be using to store 3 axis accelerometer data, and ADXL 345 gives 2 bytes per each axis, so that mounts up to total 6 bytes for 3 axis, and that will be stored in this data variable. Then I'm declaring a character array for string to print, and it's a byte it's a variable of 200 characters. This string will be formed by using this data and few other things to print on our serial monitor for debugging purpose. Then we are setting one integer variable named chip select to 10. This is the number of pin that is chip select pin for SPI interface. Then I'm declaring one random number. I'll show you why for what I'm using this random number. Then there's one character name by the character variable by the name file name of 40 characters. I'll tell you why I'm using this as we'll go on. Now let's look at the setup code for this accumulator. First of all, we are declaring one variable existence check. Okay, this was for debugging part only, and in real code I'm not using it, so don't worry about it. Then we are declaring one serial interface with this much of baud rate. This just waits for serial interface to come up, and this is just needed for linear Arduino, no use for Uno and all, but just for safety I'm keeping this. Then we are declaring one we are printing one line on the SD card, on the serial monitor, that is initializing SD card. Then we are making pin number 10 as output, and here we are checking whether SD card is present in that SD card module. If it is not present, then we'll put this error message. So this part of the code deals with checking of SD card existence in the SD card module, and if it's present, then we'll put this data card initialized as on our serial monitor. Next thing, we'll begin the wire interface, that is we are starting the I2C interface. And in I2C interface, the way data flows is like, first you give the address of the slave, then you write whether you want, then you tell whether you want to write into the register or you want to read from the register. And then if you want to read, then the slave will reply with the required number of bytes that you have requested. And if you want to write, then after giving the address of the register that you want to write, you put the data that you want to write. So here we are writing into the address register with the address 0x2d, which is a power control register, and we are writing it 0. So we'll make each bit of this 0x2d register to 0. This is just to reset this register, and the next step will be writing 8 to it, which is for enabling the measurement in, so by writing 1 at the fourth place from the right, we'll put ADXL into the active mode or measurement mode, so it will start measuring the reading. And then next we are writing some bits into 0x31 register, which is data format register, to maximum resolution, and plus or minus 8G as the maximum value of G. So this part will do that thing. And finally we are setting the sampling rate of ADXL, and we are writing it into 0x2C registers, and this is the order of bytes. And you can set to whatever rate or whatever resolution you want to keep by looking into the data sheet and writing into this register. So this setup code will set all things for us by setting the proper registers, and these are the registers needed. If you run this code, definitely ADXL module will run it, by assuming that you have made all those connections properly. Next thing we are doing is putting one random seed, reading this analog read 0 pin for generating some random number. And I'm using this to, like, each time I will power my Arduino board, I want my data to be stored in some file, because I'm opening my file into write mode, and if I write it to the same file, if the file is existing, then data will be overwritten. But I don't want to do, I don't want to overwrite the data. So each time I power on my Arduino board, it creates a new file in the SD card and start logging data into that part. And to name that data file, I'm using one random number concatenated with this file name. So data %d, this %d will be replaced by the random number generated in the range of 0 to 3000. So that gets placed there, and a file with the name, it's not created here actually, it gets created in the void loop, but this is the file. This statement will create a variable. That's this file name here. See, this is the file name, is the variable that we have declared here of 40 characters, and that gets initialized by that random number generated and concatenated with data and gets stored into this file name. So now let's look at the loop part of our code. So in the loop part, first of all, I'm declaring variable called xyz register with value 0x32, and this is the address of a register x into ADXL, in the accelerometer ADXL 345. So this hex address points to the x-axis data register. Then 0x33 will point to the next, the other byte of x-axis value, and 34, 35 will point to the value of y-axis, and 36 and 37 points to the z-axis value. So these are the 6 registers which will be reading, and that's what we do here. So we'll first write like begin transmitter to this ADXL module, and this is the macro that we have declared at the initial of the code, where it says 0x53. This is the address of our ADXL module, and we says like begin transmission to that, and we'll write this register and end the transmission. Then we'll request 6 byte from this module, and then we'll read it using this while loop. So you can go to this while loop where we'll read each byte and put it into this data variable, and I have put suitable comments to what thing they do. So like write.available will return the number of bytes available for retrieval by this read function, and read function will read each byte at a time and put it into this data variable. And finally we'll end the transmission, and this part will put all things into and put the data properly. So the value that is stored in data 0 is concatenated, or appended to left shifted 8 bits location with data 1. So by doing this, we'll create a 16-bit variable, that is x, and data 1 will act as the higher 8 bits and data 0 will act at the lower 8 bits. So that is the way we'll construct all those x, y and z variables, and these variables will be storing the value of proper acceleration measured by our accelerometer. Then these statements form a string with a timestamp. This means variable puts a timestamp for our data, and next what we'll be doing is, like, if the number of readings, if you remember, count was the variable that was counting the readings that we have taken, is less than the measurements that we want to take, then we'll get inside, we'll open a file with a file name that I mentioned earlier, and if the data file exists, then we'll put that this string into the file, and we'll close the file, and we'll also send it to the serial monitor, so that helps in debugging. And if the file doesn't exist, then we'll put this error message. So this if loop puts the data in the SD card, and this thing will keep on executing in the loop and take the reading in regular interval. So this is the code by which we'll put the data inside our SD card, on which we'll do some analytics, and I will mention the link to this code in the description, and feel free to look at the code. And now that we are done with our coding and all hardware requirements, let's put everything together and wear it on our ankle. So I suggest we'll put some styrofoams on top and bottom of our battery holder, as I have shown, because if you don't put that, then the sharp edges of this battery holder will hurt you in your ankle, and nobody wants that to happen. So this part will be facing our ankle, so we should put this styrofoam so that it doesn't harm our leg. On the top of that, I kept my Arduino board and the breakout board that I have designed, and everything was stacked up, and between each of this thing I have kept styrofoam, so that there is no short among these, any kind of open projection from the back or top of the boards. And this is how it looks, everything stacked up. And this is the power cord, so you just put this cord inside this connector, and everything gets running. Then I wrapped everything around the tape and stick it to my ankle. And I know this is not the way exactly we should do this. We should make some 3D printed case or something like that, but I don't have any 3D printer, and I ordered one box, but it could not accommodate the whole assembly, so I had to go with this method. And I think for data collection and beginner, it's okay to wait and order other box instead, just move forward and go ahead. So these are different angle view of this same thing stuck to my feet. Here I made I made a hole so that I can connect this power cord to the board. So this is how this is how my leg I look. And one thing here is that you should keep a note of which orientation you kept your accelerometer, so that you get some intuition on which axis should be giving proper data. And few time you will remove your this accumulator and again stick it there, and I suggest you keep the orientation of accelerometer same in all those readings, so that there's a uniformity in the reading. Otherwise again we'll be looking at like which axis was the one we will have to look at, and we can develop algorithms for that also, but as a beginner in machine learning and all, I think we should keep orientation fixed. So that's what I suggest, and this is how we'll end our first part of this small mini project. Thank you for watching, and I suggest you subscribe to my channel for all those excellent mini projects. I suggest you even look at my previous videos, and thank you for watching.